Hey, what's up, guys? Okay, so in this video, I'm gonna talking about the idea basically is or some this is the interview question that people like to ask. So basically, we are talking about uncorrelated but not independent XY, but not independent. Okay, so let me just quickly review. So we know though what's the definition of independent probability distribution, and the uncorrelated basically means that the correlation is zero. Okay, so recall that the correlation of xy will be the covariance of xy divided by square root of variance x, and this basically the variance of y. Okay, so if this is zero, basically means that the covariance is zero. Okay, and the covariance of xy by definition will be the expectation value ratio xy and the minus expectation value x and expectation y. Okay, and for if you have linear this row, right? If you learn in high school, basically this tell you that if your two distribution are linear independent are linear to each other, then you can use this correlation coefficient to check that whether it's dependent or not. Okay, but for this video, I just want to give you some very simple example that uncorrelated but not independent. Okay, so our goal is to construct. Our goal is to construct x and y, right, such that row of xy is zero, but x and y are not independent. Okay, and, so I will give you the some examples, and we will see that maybe there's a general construction of lots of such examples. Okay, so let's consider example 1. So I can consider x to be the Gaussian, so 0, 1 of the real Gaussian, and I define y to be the x squared. Okay, so obviously that let's compute the covariance of xy. So it's expression of xy minus expression x and the expression of y. And since it's expression of x cubed and the expression minus expression x and the expression y. And obviously that since it's Gaussian, right? So expression x is 0 and the expectation of x cubed is also 0, right? Since x is Gaussian. Okay, so it's 0. Okay, and yeah, so this first one. And another example that, by the way, they are obviously dependent. Okay, so there are another example, a very interesting example that, for example, you can take U, right, to be like, let's say, use a uniform distribution. So it's uniform from, like, let's say, 0 to 1. Sorry, 0 to 2 pi. And you choose your x to be like defined with sine u and the y to be cosine u. Okay, and you can check that x and y are dependent, but let's compute the covariance of x, y. The expectation value of this sine u, cosine u, minus expectation of sine u, and cosine u. Okay, and obviously that since so expectation of x, right, is basically the average of sine will be 0. The cosine will also be 0, but this guy, right, is a half of sine 2u, right, so also be 0. So 0 minus 0, 0. Okay, and okay, there are another simple example which you can choose x to be u minus 1 to 1, basically uniformly from minus 1 to 1, and also still take y equals x squared. So you can take the expectation x is 0, right? And the expectation of y, which we don't know, right? Who cares? but its position of xy, right, still 0 because it's like the odd function. Okay, so then we have a way, right, to develop a lot of simple counterexample. Okay, such example is easy, right? Let's say consider x to be center at 0. So let's force expression x to be 0. And we suppose the PDF of x is even. PDF of x is even. And let's say supported on negative a to a. Okay. And we want to find let's say y equals f of x. So basically, simple way is that we want to find f such that the covariance of x and f of x is 0. Okay, so very simple. So this is just expression of x, expression of f of x, minus expression of x and f of x. So this is this. Okay, so negative and the plus. So it's expression of x and f of x. Okay, so this is just the integral of f of x dx a negative a. Okay, so obviously that you can see that any so if this guy is an even function, then that it would be good, right? So sorry, it's not even function, it's odd function, right? If it's odd function, then it would be good. Okay, so any f, right? Any f of x. Sorry, I forgot stupid thing. This is incorrect. Because now f is just xf, so I need to times the PDF. So let's say this is p of x. Okay, so it's p of x dx. Okay, so in order to make this guy to be 0, we need this guy, this x, f of x, p of x, to be odd, right? To be odd. So this means that f of x, yeah, p of x, I hopefully to be even. But since p of x is even, right? So we just need the f of x to be even. Okay, so anything that this type of counterexample will simply works. So if you choose f of x to be even, then it would be good, right? So you can see it's even, and the previous that you can see even, right? So any center and the tag even will be good. Okay, so very simple counterexample. Okay, just a very simple problem that you can check, and see you guys next videos.